Okay, welcome everybody. So my name is Matthew Rockland, and it's my pleasure today to introduce my old bosses, actually, Peter Wang and Travis Oliphant. Before we get started, I want to say a few minutes introducing them and sort of their role in making this conference possible, and sort of lots of other things too. So if for some reason you don't know them, Peter and Travis has done tons of work in our community. They both founded Anaconda together, and then many other companies since. And also leaders within the open source community. They've created software, they've caused software to exist like Numpy, SciPy, Conda, Dask, Numba, Bokeh, and sort of made space within the whole ecosystem for these kinds of, not just software projects, but sort of ecosystem changing software projects. They're really sort of ecosystem hackers is the way that I think of it. Safe to say that none of us would be at this conference without them, that Dask wouldn't exist. It's also pretty likely we wouldn't be using Python today, right? So they've done a lot of this ecosystem hacking. They've also, through Anaconda, helped to move Python beyond just science and hobbyist activities to for-profit companies, to larger organizations, education. They've really helped Python to transform the way all of us work. Specifically about Dask, I joined Anaconda 6 or 7 years ago, and they made space for open source developers to work on these really far-reaching projects, right? Dask was not a moneymaker for Anaconda. And making a company which makes space for projects like that requires a certain amount of vision and a certain amount of sort of multi-year perspective. And that's quite rare to find in the world. And so I think Peter and Travis have many qualities, many faults, many virtues, but they certainly multi-year perspectives and vision, something that they're very rich in. So I'm really happy and really excited to hear from that perspective today, especially from a pair that has a proven track record of changing the way in which we all work. So with that, Peter and Travis, I'd like to hand it over to you.
Thank you, Matt, for that really kind introduction. Yeah, when you put it like that, wow, sounds like we're really a thing, Travis.
I know. I'm a little concerned. How are we going to pull that off? Hey, Peter, you want me to share my screen and then you can start talking from the slides I've got?
I actually added a couple of slides. I made a couple of small modifications. If you don't mind, I'll share my screen and then we'll switch off to you.
All right,
when I'm done with my little section, and then we can, yeah. Okay, let's see here, share. And I think, is everyone able to type into the chat?
Yes.
Okay, great. So, oh man, that's gonna be a lot of fun in there probably. We'll see. The heckle. It's going to be people heckling me here. Okay, so we decided to talk about, we thought about what we talk about with the Dask conference and a keynote worthy of this summit. And what we settled on was talking about something I think is relevant to where Dask is in its evolution, and is also something that really I think Travis and I together can have a great conversation about. That's something near and dear to both of our hearts, and something that we've been working on for well over a decade. I mean, in the case of Travis, 2 decades. And it's something that we decided to call it sort of humble scoping, and really trying to understand and talk about the DNA of open innovation, in this ecosystem, and what we've seen over the years. So as I've given talks in the last few years, it's really the last, I would say, 2 or 3 years, starting around 2018 timeframe, that I started putting together slides like this. And this is from my PyData Berlin PyCon DE keynote in the end of 2019. I think the last major big conference I went to before the lockdown happened. And I put a slide together like this, something relatively provocative at the bottom. Everyone focuses on that, right? What do you mean you've out-leveraged human labor and out-innovated capitalism? That's a pretty big claim. And every now and then, to get more followers on Twitter, I tweet out this image. And every time I do, I get about 100 new followers. But then I also get pushback. People are like, well, what do you mean by that? Can you clarify? And one thing that is interesting when I think about this, there's a quote that if you want to go fast, go alone. If you want to go far, go together. Someone calls it an African proverb. I don't know if it is or not, but let's pretend it is. But I think when we look at the ecosystem, we've actually managed to do both. We've created a space where people can go fast, people can go together and go far, And we have some projects that have done both. They very quickly create a lot of innovation and continue to be used by lots of people. And when I talked to Travis or to Matt Rocklin and Stan Seabird and others kind of in the Anaconda orbit around this kind of stuff, something I think a perspective that we all tend to share is that the projects that have done really well over the years are ones that have a common aspect, which is that they have we call it humble scope, or they have maybe something you call minimum viable scope. And in projects that do that, they have this trajectory, right, where you start by building a useful thing. Someone's trying to, do an afternoon project to explore something, but then that quickly turns into something useful, and they keep working on and hacking on nights and weekends, and then it becomes useful for a lot of other people because they share it. And at some threshold of adoption, what ends up happening is they stop trying to build all the things. They stop trying to have it be this multi-tentacled thing that wraps everything. And they start building interfaces and say, well, no, you care about this part of it so much. Why don't you go do that? Patch is welcome. And this part, you go and do that part. And a lot of the projects that we look at in the ecosystem that have evolved in this way, that limitation of scope is because, to some extent, the people who created it were scientists with day jobs or assistant professors who needed to get tenure. And they just simply didn't have the bandwidth, nor did they have the aspiration to be like the uber geek that, oh, if I were to build this whole thing, I would make it to the top of Hacker News. It's still like, I don't have time to solve that part of the problem. Why don't you go and solve that part of the problem for yourself? But I'm going to solve this part because this is what I need for my thesis, right? And that little tweak of the fact that we have scientific programmers, scientific computing people building these tools and doing this, it sort of naturally created natural limitations of scope. But in other cases, and I would say, maybe, and Travis will talk about this in more detail later, in the case of Numpy, there was, it came kind of ready-made with sort of a scope like, well, here's kind of the minimum viable thing I need to build for it to be useful. Let me see if I can at least do that, right? And he'll talk more about that. But in any case, in all these cases, whatever the reason, the projects that have done really well have hit, a threshold of adoption. They solve a lot of problems, and then as people take it to go further, people put in interfaces, and then more people can build. So this sounds like, in retrospect, you can retcon this to sound super smooth and obvious and great, but in reality, it's extremely hard. And it's hard not just for organizational design reasons or API reasons, but it's hard actually because it requires the project leader themselves to transform how they think about the relationship with the project and with the community, and with former users now turned peers on the project. And when we together were building Anaconda/Continuum, at one point when we hit a particular inflection point in growth, we were seeing all these organizational challenges. And there's an article that someone found that I thought was absolutely excellent, and I recommend it to anyone who's growing an organization and doing startup. And it's this idea of the concept of letting go of your Legos. And so this particular blog post about Molly Graham's articulation of this principle, it's about building companies, but the same thing can be said about software projects and open source projects. And she articulates it really well, right? That when you first start, there's so much you could do. This really could be an amazing project, the most amazing Uber like thing. And so there's lots of Legos. There's a giant bucket of Legos that you could go and take and build from. And as more people show up, now they're starting to take the pieces that you wanted to use to build this thing. Now they're starting, and if they start building a thing, then that kind of eats up on your vision, right? And they're going to build it wrong. What if they build it wrong, right? Really, maybe they should stop. They should give you those Lego pieces back. You'll go take some time next week to build a thing, and they can then build it, right? And this idea that as a leader, as I guess the original creator of a project, when you get to a certain point, you have to develop this internal skill to let go of your Legos and let other people build things in their vision. And so when we talk about humble scoping or humility there, it's this idea that you actually, have humility of vision on some of these things. It's very, very difficult, exceedingly difficult to do. Because the other thing is that when you are the creator of a project, you have to have vision. You have to say, I don't care if the rest of the world thinks I'm wrong, I'm going to do this thing. So you have to have the combination of that kind of like that courage and that maybe a little bit of like obstinance. But then when you start getting people coming in, you then have to switch 180 degrees to be very humble to accept other people's input in the vision. Very, very difficult thing to do. But with open source projects that are successful, all the leaders essentially have to make this transition. And for our ecosystem in particular, and this idea of humble scoping, I think where I found someone else articulated something that I think is very, very insightful about this dynamic. We're not the only ones going through this. And in fact, Clay Shirky, one of the foremost thinkers about crowdsourcing, in his book, Here Comes Everybody, he lays out this step-by-step kind of breakdown of how you go from building a thing to then building a collaborative environment and really successful crowdsourcing, which is what open source is, right? It's crowdsourced innovation and software development. And so you start by building something useful for yourself, and he calls it the me first collaboration. Then you start talking about it and people come to learn about it, and you teach them and you mentor them and you answer the questions. And then a collaboration starts to form, and there's a shared purpose throughout doing the work. And then, and he says most projects, Clay Shirky says that most projects don't get to step 4. They sort of just get to step 3, collaboration, and they either get stuck there or it falls apart. People get angry at each other and it kind of explodes. But if you can get to step 4, then that's the step of collective action, where we see that we're not merely all sort of collaborators, mere collaborators around thing and aggregation. We have a shared destiny. We have a shared fate. And to some extent, I mean, Matt, I had no idea that you're gonna have such a kind introduction for us, but I think when we set out, Travis and I set out to create Anaconda or Continuum and the PyData ecosystem, NumFocus, all of these things, that was us really trying to take the first step in that collective action sort of regime, right? The view that, hey, the collective fate of everyone in the Python ecosystem, we're all going to suffer unless we come together and really put some things together that give this longevity, give this ecosystem and these tools longevity. Through this kind of evolution, what you see is that projects stop becoming simply shelling points or water coolers or watering holes or oases in the desert, but they actually, once they start getting enough people and a village starts to form around this little spot, these successful projects, then they go from being tools to becoming interfaces, and actually holding and defining that interface, keeping it open, allowing new things to come in without disrupting the old maintenance stuff, letting old maintenance needs not hold back innovation. This ratchet mechanism, that becomes actually the work. That becomes a really hard thing. So as I think about the projects that have been successful that have come within the community innovation-based ones, versus, let's say, sole vendor-backed or VC venture company-backed, sort of like just this is company X open source library Y, use it, love it, take it to production, and then now the company's worth $1 billion, right? And that kind of dynamic, that innovation doesn't come from the community. But in our community, the innovation that's kind of arisen, all of these tend to become these interfaces become really a utility. They become this commons where many different parties can come and trade off risk and labor cost and value and innovation. So that this idea that this is a market square, this is a little watering hole in a commons, that is something that I haven't heard other people articulate, but to me seems so viscerally true when I look at what's successful. When we compare it to open source projects and frameworks that come in and try to own the world, versus this little aggregation, these Lego pieces and studs that all connect together in the SciPy and the PyData community, I would say this is the biggest difference. And I think that this is relevant to the current point in Dask, because it is starting to get a lot of adoption. There are starting to be a lot of users who want to take it in lots of different directions. And one of the things that Matt did well in the early days, I think, was to architect it in such a way that there are several different pieces, and those are natural places to build interfaces. But we'll get that in a second. What we thought we would do is we would talk about case studies in this, and we start with Conda, then Travis would talk about NumPy, and then together we talk a little bit about Dask, and then hopefully we have some time for questions. And I realized I didn't actually hit play on this, which is why I'm not getting any of my builds. Can you guys still see? Hold on, let me resume share. Can you guys see that, or or not?
I see a slide that says case studies, Conda, Numpy, Dask.
Yeah, I think Zoom is not okay. What about this? Did it advance?
Not yet.
Okay. Let me. So this is clearly not working. I'll just do it this way. Can you see it again? Now is it Conda?
I see Conda. Yes.
Okay, we'll just do it this way. Sorry about that. So, well, I'll just read through, but don't read anything except the first line right now. Pretend it doesn't exist, all right? So with Conda, it went through this evolution. We started, actually a little point of trivia, we created Anaconda before Conda, right? So the very first Anaconda that came out was just a omnibus installer of all these libraries, just a one-click installer kind of thing. That came out in June. I think the first release, 0.7, was June or July of 2012. And then a few months later, we had kind of gotten the idea that we should build a package updater mechanism and build that into Anaconda, the distribution. And so Conda started by being this very tightly scoped little tool. It was there to install and update your local packages. But when Travis and I and Brian Van de Ven, Elon, and we're talking about it, we had this idea that if we build it correctly, we could actually do environment isolation, since we're building all the packages anyway. And so then it evolved into being able to create, Conda envs and having really nice user land isolation of C libraries and things like that. And as the scope for Conda grew, I mean, you can imagine when you're starting to basically recreate userland Linux environments or MinGW or Cygwin, there's a lot of scope. You could do a lot of different things. And we did kind of go down the rabbit hole a little bit of trying to solve all these problems. And Elon wasn't sleeping, and lots of people were not getting enough sleep and all sorts of stuff because, just even getting package builds correct was a hard problem. So we had a build tool, we had an automated build system, we had a recipe system that had a template sort of processor. There was the installer itself on all the different platforms, all these different kinds of things. And then the question of how do you work with pip? How do you work with virtual env? How do you work with Docker? So the amount of demands on Conda, this little package updater tool, the amount of demands grew tremendously. And initially, I would say maybe up until about 2015 or so, there was some sense that we were just gonna, we're like ducks, our feet would just go faster. We're gonna try to solve all these needs and try to meet all these needs. And then it just, it became, clear to us that we couldn't do that. We would have to rely on the community to, I mean, it was always an open source tool. We would always accept input, but really the idea of the vision of the project and how we drive it forward and all these things, with the creation of Conda Forge, that actually pulled, in a sense, the architecture of Conda to where we broke out Conda build as a tool, to where constructor, right, the installer builder as a tool came out, the recipe system, and really trying to standardize the recipes. All of these things became discrete things we had to build, and to some extent, anaconda.org and the software architecture behind that also came out as a separate piece. So all these different pieces sort of emerged from different drivers, and we created interfaces around these things. And it's a good thing we did, right? Because there's no way the ecosystem could have been successful had we not harnessed the energy and the power of the Conda Forge community and all of the contributors around Conda. So the other thing I would point out about this, though, and be somewhat blunt about this, to make that evolution, certain individuals and project leadership, we had to basically make organizational and personal sort of development changes in order to be able to do that, right? And so to me, the Conda and the evolution of Conda kind of along this journey is a perfect case study in this idea that software isn't just the code alone. It isn't even just the organization. It's individual people in the organization where they are at in their personal development can have night and day differences, on the evolution of the project. And that's Conda. Travis, I'll stop sharing. You can share your slides on Numpy.
Yeah, sure, Peter. I think we can love to chat about Conda just a little bit, maybe a little back and forth
Sure.
on this, and then you can invite you to comment as well as we talk about Numpy, and I'm going to talk about SciPy too, actually, because I think it's instructive. And then we get to Dask, and I know we don't probably have a little bit of time, but I think if we start the dialogue, then we can maybe invite a few other folks, maybe for the last 10 minutes, to kind of maybe ask questions, and maybe there'll be some dialogue about that too. You bring up some amazing questions and some amazing observations. I've always loved working with you. Your sort of philosophical bent and your ability to kind of summarize what you're seeing is really encouraging and inspiring. and also helpful. It's useful to take a look back, and I've done it multiple times, trying to understand, why did that work? What went wrong there? Why didn't this work as well? What were the key pieces to make this happen? A lot of times, some of this stuff I think emerges somewhat accidentally based on the characteristics of the people that get involved. I think in a lot of ways where it's beautiful, but it's also, undirected. And I think I really like the way you characterize the world today has so many really intentional top-down projects. I call them company-backed open source, where there's a lot of work that happens and there's a whole organization behind it. Then there's also this community-driven, which is somewhat more frothy and emergent, and how each of these can be successful, and then how do they intertwine, which I think what we've been doing together for the past 10 years has really been kind of how do we intertwine intentionality with community, which is a really, I think, useful, because scale and delivery of functioning software requires a lot of maintenance, requires a lot of effort, requires a lot of sustainability, requires a lot of funding. And I think it's really critical to do that. I love what you said about Conda. I think it is I don't think it's really appreciated quite just how much of a change it was for Anaconda to actually switch from being kind of, here's Anaconda delivering all the things, here's Anaconda curating things the communities are delivering. That was a massive change, to go from Conda build, particularly everything built by Anaconda, to allowing the community to build with Conda Forge, and not just allowing it, using and encouraging and trying to promote. And it had consequences for individuals that I think is often underappreciated. That is true in almost everything you see. Like when you start to see that in one place, you dig and you see, oh, this is showing up in a lot of places. And then it starts to give you maybe some insight as we start to think about the larger world. You think of the TensorFlow versus the PyTorch ecosystem as they emerge, and then kind of the look a little deeper as you start to look at communities emerging around Dask and communities emerging around Ray. So I'm going to share my screen and start talking a little bit about Numpy, and then kind of invite commentary. Let me see if I can do that. Sorry for the delay. And hopefully this works. Is that working?
Yes.
Excellent. So one of the things, it's a theme that I've often contemplated because I've seen it over and over again, is, and you hinted at it, Peter, you talked about this, kind of going to a successful project. It doesn't just emerge from a bunch of people. Like I've never seen a successful project emerge from a bunch of people just chatting. Like there's all that happens all the time. I mean, you go to the internet any day and you have people chatting, and there's sort of chatter. Now, that can inspire, but eventually somebody has to take that chatter and do something. Now that somebody, and usually if it's too many somebodies, then they can't actually get aligned, and then it goes off in 15 directions. So it usually is 1 to 3, maybe 5. Once it gets past 5, and that ability to coordinate kind of diminishes. So it's really this interesting conundrum between how do you get the passionate one, the passionate few, to do a lot of work, and then, as you described, pivot to encourage and allow and promote a project that has many contributors. And it is a very, I think there are characteristics of people and characteristics of what you do and what you attributes do you enjoy or you promote. And even if you don't have it, maybe there's other people in the community that do. I mean, that's one of the nice things as well, is it actually doesn't have to all reside in one person. Like if you bring the right people into an organization or a community or a group of people that can display some of these characteristics, you can actually help grow the community, even if a single person can't. So I say that in a way that some of these are hard, and you mentioned it's hard, but I want to be encouraging that regardless of your capabilities or skills, there's a piece you can play, there's something you can do. And even if you're technically capable, but maybe you're not quite the community evangelist or the developer advocate or the presenter that you'd like to be, great. You just gonna have to find somebody who will do that and partner with them along the journey. So Numpy, it's instructive, I think, to understand how it got started. It started as a passion project. It started as it was actually SciPy that I was concerned about. SciPy was my baby, basically. It was the thing I was really passionate about. And it was starting to be at risk as the array community was fracturing, because libraries were being built on other array objects. And then it was, okay, I'm going to go up in memory, and I'm going to have copies of data floating around in memory, and despite memory growing, applications can blow up memory. And that's still true today. Even though memory keeps growing, there's more data than memory. especially near-term memory. So in January, I started merging these two previous libraries. I did it by not doing what I was supposed to be doing. So as you described, there was no funding for it. There's nobody that said, go do this. It was basically a me kind of, me wanted it. I wanted this thing. So I just started to do it. And I had a little bit of time. It took some time before anybody else was willing to jump in on that. And that's not a criticism. That's sort of an observation that's always true. Like it would be irrational for somebody to jump in on a passion project that has no idea whether it's going to be successful, unless they too also are passionate and get excited about it. So it took time, maybe 6 months, for anyone else jumped in. But once there was some suggestion of viability, so the key was to kind of build until there's something working. Build until something's working and people can see, oh yeah, that's actually faster than NumArray, but more features than numeric. Hey, that might work. Right, that was kind of the key. And yes, you're right, the scope was there. It was very helpful to have a scope that was already there. I wasn't trying to invent this thing whole cloth. It was very helpful. But then there's key people that jumped in. Robert Kern, Charles Harris, they provided significant help to get to version 1, adding random number libraries, adding a lot of tests, a lot of functionality. So it was really critical, those key people who come to the project early. And a lot of what you end up doing as an early contributor to a project is recruiting some of those key people. When we at Anaconda, I felt like one of the things we did, and I appreciate the way Matt says that, create a space for innovation, create a space for people to come together, was do that. Create a space where somebody has time to work on something full time. I remember as we talked, we created Anaconda, or Team Analytics became Anaconda. We intentionally wanted to do that. So open source is too important to leave to volunteer hours. We've got to hire people and find funding and ways to pay them to work on open source. And I'm really proud of the work that we've done, and then the learning that's taken place to allow even more work to be done outside of that, to create space for people to do it. But also with some of the learnings, understand the pieces that had to be in place. It's not just enough to fund the one amazing developer. How do you actually encourage the community and create the accoutrements around that person so that they can, the PyData ecosystem, the conference series, places they can go, evangelism can occur. I think that was very critical, and it was intentional as well. It's not just simple. One of the things I realized is that early on in NumPy's growth, it was connecting to the people that were there. I went and met Guido and Paul Dubois, who was the current leader of Numeric at the time. And I went with Perry Greenfield, who was the leader of NumArray, right? Intentional interfacing, human interfacing with people. With Guido, it was about, trying to figure out how to make a space for NumPy in the Python ecosystem and understand. Conda was a similar story. How do we do packaging in the Python ecosystem? And meeting with Guido and kind of hearing that, well, solve it yourself is going to have to be how you solve it. I mean, these are important, I think, realities that emerge. We'll get to Dask a little bit later. It was sort of the context of Dask in an Xdata project where there are lots of participants understanding how do you do this and enable and allow Python participants to scale their work as well. There's some, use SciPy as a test platform. It's kind of, I joke about this, but it's kind of sad. I mean, I don't always test, but when I do it in production. There are a lot of SciPy users as NumPy was coming out early that ended up, going along with the journey of making sure that the features of NumPy worked. And then there was a lot of difficulty. I mean, packaging has been long a difficulty in this ecosystem. And one of the reasons Anaconda exists is because there's a lot of difficulty. We had to rewrite distutils in NumPy. Along the way, you're going to find those key difficulties. Often, those key difficulties become opportunities. And so it's one of the great pleasures of working in open source ecosystems, emergent ecosystems, is meeting people like you, Peter. I mean, I know you because I did this, right? Meeting people like Matt Rocklin. Know Matt Rocklin because we did distributed computing and said we wanted to build something bigger. That's, for all the challenges, probably the greatest joy is the fact you get to interact with so many amazing people. So it's definitely worth the effort and worth the pain. I don't know if you want to comment on NumPy at all, Peter, as you recall kind of observing some of that behavior, or kind of what's emerged since.
Yeah, two things there. Just when you put Robert Kerr on there, I think when you talk about that, there's lots of talk. Talk is cheap. Lots of people can talk and argue, but ultimately somebody has to write the code. And I don't know if you remember, there's one time at a SciPy conference when Robert Kern sort of said, well, there are all these people arguing about this thing. I decided to just go write some code, because working code resolves all arguments. And it's true, right? It's like you can have all this sort of a potential energy, but as soon as you get a nucleation site, something happens there. A seed crystal emerges. And the mathematics, I think, of human collaboration and stigmergetic emergence, and the mathematics of seed crystals and crystallization, I think, are quite similar. It's actually not that different at a mathematical level. The other thing is, when you talk, I'd forgotten about this NumPy distutils thing, and you're right that when we had our first PyData conference or workshop at Google, and Guido did give us permission, that was actually a really critical thing. And in the years since, I've constantly I'm so glad we captured that on video, because I have the video evidence, and it's not, deep faked. It's like, he told us to go ahead and do this, man. I wasn't being a jerk. I mean, he told us to do it. And so, he gave us permission to go and solve this problem. And I think that in that one stroke, he probably saved a tremendous amount of fighting and contention, because our inclination, I think in the Python community in general, we would try very hard to work with each other, even if it meant that we got really mad at each other, because we understood this deeper value that, look, we shouldn't fork the ecosystem. It's not about forking a project, it's about forking developer attention, right? And to your point about NumPy coming from the NumArray and numeric kind of thing, I mean, I felt this viscerally as a developer at Enthought, and working on plotting libraries, working on applications for clients, constantly I'd sit there and be like, well, do I want to use NumArray for this? Do I want to use numeric, or do I use the numerics.py and hedge my bets and not use either of the great capabilities of either? No fancy indexing over here, and it just, that was everyone was held back by the inefficiency of that, right? So I felt myself split as a developer. So yeah, I mean, this all comes from a lot of lessons learned there throughout that process.
Yeah, I appreciate that. And it really, I think good projects, great projects have to start with a need. You have to start with a thing you're solving, a pain you're eliminating. It can't just be all highfalutin conceptual ideas you're going to build everything. It's like, you got to solve a pain point, you got to solve something. And I like the notion of humble scopes, in the sense that you can't solve everything, but please solve something. But it has to be added to it, please solve something. It's got to be just good enough. It's got to be big enough and good enough. It can't just shrinking the scope isn't enough. It's shrinking it to just the right size. And I think it's a lot about interfacing, a lot about engaging, a lot about empathy and other focus, I think is the heart of it. It's sort of, and that's a very interesting combination. SciPy is another case study, I think, and it's more complicated. We won't have time to cover it in detail here, but I think it's illustrative to talk about another project. SciPy started in late 1998 with a bunch of people talking. I love the matrix sig. This is back before the way we communicate today, social media. It was email lists, and so it had its own cadence, and it was a little slower, and you could read an email for the day. But I was religiously devoted to this matrix sig list. I would read it every day, respond once in a while, and then learn so much from people that are writing there. Conrad Hinson, who's still writing today, he was on that list. Paul Dubois, David Asher, I mean, many people, Paul Barrett. They were all writing tools and kind of wanting, wishing that there were this library of tools that could be like a scientific computing ecosystem. And I'm like, well, great, let's start writing some tools. So, I had more time than sense. I was a graduate student, so, it's no big deal. I'm not getting paid much, and nobody's expecting anything of me. I'd finished my coursework, and I was supposed to be doing my research, so let's do this instead. And I started writing a lot of just writing C libraries interfacing to Python arrays, to numeric arrays at the time. Released those libraries as multi-pack, and actually as individual libraries initially, but the problem of distribution was real. How do you get everything installed? And so the multi-pack essentially was an installer. So you get all these packages involved. And then that's when I first met Robert Kern, actually, very prolific in this community. Largely, he made exe files for Windows.
He was a high school kid at the time, right?
He was a high school kid at the time. Yeah, I didn't know this, but he was extremely helpful. And I noticed a huge adoption curve go up once the exe files were available. Like, tarballs, turns out, pulling down a source code and building yourself, that limits distribution. And one thing that's very true about humans is if it takes more effort, you're going to do it less. So if you want people to do something, make it super easy, is a very simple concept. P.R. Peterson helped improve the Makefile. That started a relationship that's, I'm really thrilled where I'm working with him today. It's awesome that he's back in the community working hard on a lot of integrating PyTorch with the rest of the community now. But and then Eric Jones, Travis Vaught, and Enthought promoted this. One of the key things that they did was actually create this SciPy conference and promote the community gathering around this ecosystem, because the SciPy project itself ended up being massive, too massive without the sustained funding. I'm not going to say you can't do a massive project, but the amount of money it takes to continue to promote that massive project, we saw that at Conda, the amount of money it would take to sort of top down drive an ecosystem grew and grew and grew and grew. And I think you're seeing that today with TensorFlow versus PyTorch. Frankly, I think you can put a lot of money into something, but it's going to keep taking more and more and more. What you have to do is get, derive that labor and that effort from a large number of people. Like at the end of the day, what Scott McNeely said, I actually may not be attributing the quote correctly, but there are more smart people out of your organization than are in your organization. And that's always true.
I think it was Bill Joy.
It's Bill Joy. You're right. I think you're exactly right. It was Bill Joy. But there are more people, smart people outside your organization than inside your organization.
It's definitely not the kind of thing Scott McNeely would say. Sorry.
Fair enough, Peter. I appreciate that. So initially, SciPy tried to be everything. And the reason, again, was for simplicity. It wasn't actually for ego. It wasn't because we wanted to do all the things. It's because we wanted to provide a place where all the things could get done. And so it was interesting as SciPy emerged from the early 2000s, instead of wanting to be in charge of everything, is just wanting to make it simple so things could get done. But the key was unlocking community. The key was unlocking a bunch of people. And then, as you can see over the years, Matplotlib, Pandas, not just the scikits, scikit-learn, scikit-image. There are a few scikits that have grown in popularity, but it's the concept of splitting from a single monolithic to many individual projects, integrating together, that was the key. I think we're still working on the integrating together, though. I think, Anaconda, certainly one of its key contributions was a part of the integrating all together. How do you get all this stuff? That's one of the key things that made Anaconda valuable to the world was, man, I'm going to spend weeks building my distribution. And SciPy, really, I say it's the first distribution. It was a library, it was a distribution masquerading as a library. But there's a lot of stuff that was learned from that experience of how important community was. And then, as you described, out of this learning came, hey, we got to create NumFocus. We got to create an organization that enables community to come together in a nonpartisan way, in a way that can be a commons area, that and then allowing a rich ecosystem of things to develop.
If I could add a comment to that, as you're saying that, I couldn't help but think about, it's like a creature growing, and you have a bone, like a skeletal structure, right? Mm-hmm. But then as part of it gets stronger here, or there's more weight over here, you have to break your own bones and basically create a joint to articulate, right? And I just kept thinking reticulating splines. But basically, as the line becomes more and more curvy, and as you want to wind your way through a more and more complex gradient or landscape, more complex landscape, you've got to start breaking bones at places so you can branch and go and do all these things. And one of the things, to your point, what we did with, and I didn't appreciate until several years in when you pointed out that part of the reason why SciPy sort of had issues was because we didn't have a packaging system for it. We've had namespace packages, and we had ways for people to build little things and plot them and pull them in. SciPy would have just been like a meta package. It would not have been this trying to wrap the whole world in one mega toolbox. And it took me years, actually, after we founded the company to understand, oh, right, because you have to suffice all the layers. You have to actually get the bits, have the right people who are building the interesting bits, then build it, distribute it, and make it compatible with everything else in the ecosystem once distributed, right? That's a lot of little bones to break along that line.
It's fantastic metaphor. As always, your wonderful description that kind of cements a point. One of the reasons PyData was created actually was because of one of those challenges. SciPy as a library, SciPy as an ecosystem, and PyData as an ecosystem, both focusing towards data and not just science, but also allowing from the beginning multiple projects. Like PyData has always been about multiple projects, pandas and scikit-learn, and really promoting just how these interoperate and what is a common ground for communication. So I thought maybe we should talk a little about Dask. We only got maybe 10 minutes left, but maybe we could talk a little about Dask and just kind of a little unscripted, perhaps. I'll start a little bit with just, Dask was a labor of love. It came out of the Blaze project, which was this ambitious effort to, remake the world somewhat. But really, it was a place. It was a gathering point.
Blaze is a 20-year vision, Travis.
Blaze is a 20-year vision.
I thought we'd get it done at 3, but it's going to probably take 20.
Absolutely, but it's still emerging. It's still bearing fruit. And one of the key things, of course, we understood when trying to do this was we got to go find people who will do it. You got to find the passionate one. Right. And an aspect of the passionate one is they're going to create something that matches what their needs are, what they think is more important. So I think one of the key things was actually, Matt Rockland, when he came down to Conda and we need distributed compute, we need to scale NumPy, we need to scale pandas. That was the fundamental mission, right? And scale happens multiple ways. We were doing a compiler project in Numba, and we could talk about Numba at a later time, but Numba was scaling the speed but scaling out, we had to have an answer, and everyone was pushing Spark. Spark was emerging at the time, and Spark, great tool, all kinds of cool things it allows, but it pushed people. They had to use a Java runtime. I mean, they don't have to, but that's where it was primarily built, and so that was the easy on-ramp. Using Spark to run Python code was harder, and the tools hadn't been developed very, very well to do that. So we were like, how do we do this natively in Python land? Scrambled a lot, but Matt Rocklin came up with some really good ideas, and I remember when we went, yeah, those are great ideas. We're gonna fund Dask. We're sort of ramped down any other funding and kind of pushed Dask. I thought that was critical. So, funding decisions was one of the key things I think that allowed Dask to emerge, and making sure there's a space that recognizes that how projects emerge, that it's not, and willing to pivot from, not just our vision, but bring somebody else with a vision and let them grow.
Well, and I think there was a little bit of pragmatism in the aspect that you and I, of course, from the beginning, had a very big vision for what Blaze, what we kind of the thing we wanted, right? We could sort of feel like, here's the thing we wanted. We have no idea how to build it all exactly. But if we got the thing we wanted, it certainly would have an ability to do Python JIT compilation and push down to advanced hardware. So that became Numba. And with Numba, you found Sue very early on, right? Yeah. But Sue and Stan then later, joined the project. Those are two personalities and individuals, very quiet and humble, but those two people made Numba happen, right? And we had other people as well involved in the project. I don't want to say there were lots of other people, but
yeah, John Reel was significant.
John Reel was significant as well, and others. And then with the rest of Blaze, so we had the push down optimized compute, but then around distributed and seamless scale up, scale out, right? And then combined with sort of data, sort of the data indexing and pushing compute to data versus moving data to compute. That was always another integral part of the Blaze vision. And when Matt first joined, he found himself swirling in this mix of Peter and Travis every other day, having all this vision piling on a bunch of people who were very lost. I think, and Matt was sort of like, well, screw it. Let's just build a distributed computing system. And there's even pushback about that. Like, why should we build a scheduler? Why should we, there's lots of these. And I think where you and I sort of, when we made the decision, let's fund the Dask thing, see where that goes, right? That was us sort of maybe pragmatically reining in the vision, the scope, and saying, well, maybe we can't get all of Blaze, but let's just do this at least, because this will be useful. And then this useful thing has taken on life of its own, right? Just as Numba to some extent has. This is, don't want to go too much detail about that here, but in both these cases, when we limited the scope and took that energy behind our big vision and basically delegated it to the vision of the people who actually get the work done.
Correct.
That allowed new things to blossom.
When I started Quantsite, one of the key things I said I wanted to do was make sure we provided scope and enabled and built people. Like, building people was the core idea, and effectively creating a space to inspire, but then find people and give them space, right? And then provide feedback, provide guidance, provide tools, kind of help them keep it out of the way, providing space. I think Dask was a very good example of that, providing space and allowing that person and then a team built around that person, smaller team, but a team nonetheless, to grow their vision without too much top-down pressure, I suppose.
Right. Well, there's two other projects. So with another part of the Blaze vision is the data catalog stuff, and we've Martin Durant with Intake has really taken that and run, and Intake's starting to kind of past this inflection point of adoption, which is fantastic. And then also on the Viz side, I've of course been passionate about visualization for a long time. Worked with Brian, in the early days around Bouquet, and then we brought in Jim Bednar, and Jim brought in his team of folks working around HoloViz and on HoloViews, really letting Jim and others take the vision around visualization, and now with Panel and with Lumen, really having kind of that dashboarding tool that we've always wanted for so long, but that letting that team kind of go and do their own thing. And I think over and over, kind of those seed things we started at Continuum, we've really, if there's one thing we've done well, I would say, is we have taken scope, given it to others, taken vision, given it to others, and let them do a thing. And now we have, it's like, what is it, the Voltron thing or whatever? All these little pieces have come together ultimately. So
how do you inspire people to kind of put a watering hole And then as they come, give them resources. In a lot of ways, that defines what I'm trying to do right now. It feels like that's what I'm really trying to do right now. I think one point, you started with humble scope, but I wanted to clarify the minimum viable scope, because there can be points in a project's history where, you know, humility can take you not far enough, right? I think this distributed scheduler for Dask was one of those times, right? Where, you know, initially Dask didn't have a distributed scheduler. Dask was a single machine core, you know, multi-process, basically a better way to do multi-processing, right? And then the distributed scheduler was kind of like daunting. Like, are we really going to write another distributed scheduler? And there were discussions back and forth, and there was like, maybe we shouldn't. This is crazy, right? But I think it's been key personally. I mean, I think the key success and the reason Dask is popular today and growing is because the world needed other ways to do distributed scheduling, and the world still may need that. I'm not an expert enough to comment, but Dask has been great at allowing Python users to schedule distributed their pandas and NumPy code. So it's I just wanted to point that out, that humble but not too humble, right? Complex, you know, not too complex but not too simple. That balance is hard to find, and in my mind, the key is to let others guide. You know, put something out there and you know, put just enough out there and then get the feedback, and then adjust it just enough to get the feedback. So it's that combination of kind of ability and humility that's so key to successful projects. And you articulated it well at the beginning, Peter, and I really appreciate the chance to kind of talk about these projects together. So I think, should we open it up to questions, Peter, or do you have any final comments? Did I lose connectivity, or did we lose Peter, Matt?
No, you're good. So okay. Yeah, thank you, Peter and Travis, for the great talk. If there are questions from folks, I encourage you to add them in the chat, and we'll go ahead and grill Peter and Travis.
I think we've lost Peter's feed.
He will figure it out. Peter understands technology. He is one with the feed.
With the feed.
So while we're waiting for questions, I just wanted to summarize little things. What I liked about the SciPy story is that you started with big scope, you then broke it down, and as a result, there was a lot of growth, right? So scikit-learn, scikit-image, scikit-foo, projects that are today possibly even more downloaded than SciPy.
Yep.
And that's really key. I think a lot of people who are in this conference, you are owning parts of Dask. They're owning how Dask deploys on HPC machines, or owning how Dask handles image processing. And so it's really exciting to see, by breaking up and being generous with scope and giving ownership early, people are able to have that kind of growth, both personally and also in the broader ecosystem.
Yeah, I think that's actually accurate, Matt, and I appreciate chatting with you in the past about this concept and that scope minimization, but then the interfaces to enable cooperation is actually really critical.
There's a question in. Also, Travis, you're also still sharing your screen. You may want to stop sharing.
I will stop sharing. Oh, thank you. Yeah, you're talking to all my people. How do we get there, actually?
So a question from Jacob Tomlinson is, are there parts of Blaze that are still missing today?
Parts of Blaze that are still missing. Yes, definitely. Blaze was so ambitious that there are always going to be parts missing. I think. I think things are emerging very, very well. I would say the data cataloging and the moving code to data seamlessly, right, is still, you see it in IBIS, you see it in kind of the SQL alchemy, you see it in that story. But I still don't think that's as seamless as people want it to be. I don't think that's as simple as people want it to be. So I would say that's one of the key questions.
Also, question from Max Grover. How do you tackle organizational barriers within academia and national labs, dealing with the silo problem?
Could you restate a little bit? What do you mean?
Max,
I think I missed the first part of that question.
Yeah, I'll restate it. So how do you tackle organizational barriers, especially within academia and the national labs?
Yeah, organizational barriers can be very challenging. I think you have to identify, are they a person? I mean, sometimes organizational barriers can just really reduce to a person. You just have to go communicate with that person, and maybe you can make adjustments, maybe you can't. or is it actually, or is it institutional? Is it like there's actually the computer science department and the electrical engineering department are separated by, there's logistics. There's in the campus where I was teaching, those two departments were actually separated by half a mile, right? So it was actually, people didn't pass each other. There was no water cooler connections between them. So, you know, each problem, the silo problems, there's logistic pieces, and maybe you have to then create, you know, opportunities for people to come together and cross each other. It might be something like that, or it might be actually people. There might be people who are just, you know, needing to be understood. They have a vision, they have a thing they're trying to get it done that you maybe don't understand. So giving a little bit to understand what they're trying to accomplish can often help too. So I think there aren't general answers to that, but all the answers are about understanding the actual problem and then empathetically serving the people that are trying to get things done.
Okay, great. Max says next, by the way.
Yeah,
okay, with that, I think we should probably close out. We're going to move into GatherTown for a bit and just give people a chance to chat with each other. Jim Weiss, the conference organizer, has just put the link into the chat. If you have other questions there, that's a good place to chat, or just, again, to meet other people around the conference.
Matt, thanks for the chance. Really great to see everybody and really great to communicate. I'll look forward to gathering in GatherTown.
Yeah, great. Thanks, Travis. Thanks, Peter.